So in this video we're going to look at expanding and simplifying a pair of brackets, and we're going to focus on, in particular, using the algebra tiles to help visualise and illustrate this. So back to look at just numbers. 23 times 14. Well, the most common method that we are using is the grid method. Now that grid method comes from this idea. So we're using the algebra tiles, but instead of thinking about the green bar as an x, think about the green bar as a 10. So along the top here we've got 10, add 10, add 3. So 20 add 3, which is 23. And along the left hand side here we've got 10 add 4, which is 14. So filling up this grid with the rest of the algebra tiles, we could use the blue square, which represents 100, like 10 by 10. We've got another 100, so far we have 200, which you know is the same as 20 times 10. Then we've got 10 times 1, 10 times 1, 10 times 1, or 10 times 3 if we want to group it and collect it like that. Looking at this bottom left sort of corner here, we've effectively got 20 times 4 and 4 times 3 in this bottom right hand corner. So if we assign, which I'm trying to describe, each tile with a number, this is what we would have. This is 10 times 10, so it's 100. Each of these green bars are worth 10, and each of the yellow tiles are worth 1. So we've got 100 add 100, add 80, add 30, add 12. So 322. So 23 times 14 is 322. But of course, by this stage, we've used the grid method a lot, so wouldn't necessarily expect us to use the algebra tiles. I would expect us to work with the grid. So we've got 23 along the top. We're using the place values and 10 and 4 to make the 14. Then we're multiplying each row and column. So 20 times 10 is 200. 3 times 10 is 30. 4 times 20 is 80. And 4 times 3 is 12. Adding up those numbers gives us 322. And that's a method and a procedure that you should be very familiar with. We can also think about that, of course, like this in the blue brackets. What we're really doing when we're multiplying 23 and 14, or 14 and 23, is we're doing 10 add 4 times 20 add 3. That's what the grid method's really doing, because we've split the 14 up into 10 add 4, and we have split the 23 up into 20 add 3. So that's where this is coming from. It's just another way of writing out the multiplication. But it relates to this idea of multiplying out a pair of brackets, because that's what we've got here. I am using brackets to contain the 10 add 4 for the 14, and I'm using a pair of brackets to include the 23, the 20 add 3. So how does that relate to algebra? Well, look at this question here. We have two expressions, both contained in a bracket, x plus 3 and x plus 4. So using the algebra tiles, that's what that would look like. We have the green x bar and then the 3 positives, and the green x bar and then the 4 positives down this left hand side. And we could fill that grid up as efficiently as possible using the algebra tiles. So we would have the blue x squared tile there. We would have 8 of these x tiles in those positions and 12 of those yellow tiles in the bottom right position. So that's what that would look like as an expression. X squared is our blue square tile. We've got 3 x's and 4 x's, and then hopefully you can see that when we're going to collect the like terms, so we're going to group the algebra tiles that are like together. So we've got 4 of the algebra tiles here, and we've got 3 of the same algebra tiles here, so we know we've got 7 of those, and we've got 12 of these. But we want to progress on to using the grid method to expand an algebraic pair of brackets like this. So here, just like in the previous example, we had 20 add 3 along the top. This time we've got x add 3 and x add 4. So x times x gave us the x squared tile. That's like 10 times 10 is 10 squared, or 5 times 5 is 5 squared. X times x is x squared. X times 3 gave us 3 x's, and 4 times x gave us 4 x's. We have 4 of these x tiles and 3 of these x tiles. And bottom right position, 4 times 3 is positive 12. Writing out each of those 4 terms and simplifying the like terms. So colour coded here, but this diagonal here groups together the x tiles, similar to what we had before when we looked at the numbers. And quite often this is almost like hundreds, tens and units. It's not quite like that, but that's a way that we can sort of think about it. Here is our last slide. Side by side are two similar looking multiplications using the grid methods. So we've got 53 times 12. We would use the grid method to calculate that. So using the place values, 50 add 3 and 10 add 2, and constructing the grid. If you think here, based on what I've just said, we've got hundreds, tens and units, and that's how this is constructed here. Okay, so thinking about the addition of the 4 blue terms slightly differently. That's 5, the 500 is 5 groups of 10 squared. The 130 is 13 groups of 10, and then the 6 units. So that's like the hundreds, the tens and the units. And that's very similar across here, but just dealing with algebra. We have the squared term at the top left. We have the x terms diagonally, and we have the units, or in algebraic terms, we would call that the constant term. Again, if we vary the position of these terms, just like if we were to vary the position of the place values and wrote the 50 add 3 as 3 add 50, for example, the grid would look different. But